So this is 8.4, and it's recognizing polynomial functions and their properties. So let's take a look at polynomials of one variable. So for example, 1 minus 5x is a polynomial in one variable. Another one could be 3t to the second minus 5t plus 1. That's another polynomial in one variable. And then maybe we do z to the third power, and that's plus 5. These are all polynomials of one variable. And the reason why it is that every one of these does not have any non-negative integers. It must not have any non-negative integers in the exponents. Okay? And so that's important to see, because if I look at the first one, the degree of this x is just 1. The degree here is 2. This one is a 1, and this one is a 3. None of those exponents are negative. And so all of these are polynomials. These are polynomials. Okay? And so if we were going to write them as a function, then we would just add off to the side f of x, or f of t, or f of z. See, so we would have that equal to z cubed plus 5. And so that tells us that. So for the first one, this one here, this one is for f of x equal to 1 minus 5x. This is a linear function. Then if you had f of t equal to 3t to the second minus 5t plus 1, this is a quadratic function. And then if you have it to the third, that would be f of z equal to z cubed plus 5. This was cubic function. After that, we pretty much just say fourth function or those kinds of things. We don't really have names for the other ones because we don't use them as much, basically. So that's kind of the setup there. Now, if we're going to identify a polynomial function, for example, we could look at some examples to see if they are functions or not, or they are a polynomial function or not. So, for example, let's clear this. Would this example be an example of a polynomial function? F of x equal to 5x to the third minus x minus 10. Is this a polynomial function? Well, yes, it is, because all of the exponents are positive. And so now this is a polynomial function. So then we take a look at another one. Let's say it was f of x equal to x to the negative 2 plus 1. Is this a polynomial function? Well, no, it is not, because of the negative that's here in the exponent. You cannot have any negative exponents in this setup. So this is a no. Okay, and then we take a look at the next one. Let's say we're looking at 3 over x minus 1. Well, because we have an x in the denominator, this is also a no, because polynomials do not have variables in the denominator. So we should write that in our notes, that if a function has a variable in the denominator, then it is not a polynomial function. It's not a polynomial at all. So those are the three basic ones you really kind of have to know to make sure you know how to do. And so that's the basics of knowing if this is a polynomial function or not.